Hello everyone. In this video, we will try to understand the concept of topological sorting, breadth first search, and these two concepts we'll try to understand through one basic problem. This problem is taken from lead code problem number 210 with medium complexity. The basic idea of this problem is there are set of courses which the student is supposed to take to get the degree awarded, and for every course there is a prerequisite which needs to be completed before the course is to be taken. For example, if I write here something like this, if I write a comma b, then it means that if I'm trying to take course B, I will have to finish off course A first. So I cannot take course B before taking the course A. So it means that there is a dependency between course A and B. This is again, we are coming to the idea of in degree and out degree. So course B, if the age is coming from course A, that is the in degree of B is coming through A, then there is a prerequisite. And once we are done with done with a generation of a sequence, and then we can say that we have generated a sorted sequence which has the prerequisite resolved. Okay. For example, if I am taking course B and if I have something like prerequisite A, then the sorted sequence will be like this, A and then B. So this is the idea, and we are assuming that we have four courses, and for these four courses there is some prerequisite already defined that there is no prerequisite for course 1 and 2, but for course 3 the prerequisite is 1, and for course 3 the prerequisite is also 2. It means that you cannot take course 3 before you have completed course 1 and 2. So if you represent this idea in the form of graph, we can actually observe that course 0 does not have any prerequisite. Okay. Course 0 does not have any prerequisite. Course 1 has prerequisite of 0. So course 1 has prerequisite of 0. Course 2 also has prerequisite of 0. So course 2 also has prerequisite of 0, and so on. So so how to actually define or how to generate a sequence so that we will be able to the resolve, or we will be able to take all the courses with prerequisite defined. For this particular purpose, we are applying the concept of breadth first search on this graph. So the breadth first search will be applied based on the node which has no prerequisite. So in this case, the node 0 has no prerequisite. So I can take, or I can initiate my breadth first search with node 0. And after node 0, which node I should take. So for that, I will be just releasing this node 0 from the graph. So if I release this node 0 from the graph, I will not have these two edges. And then after node 0 or course 0, I can take either course 1 or I can take either course 2. So if I take course 1, then I can release this no this edge coming from course 1 to course 3. So now, can I take course 3 after course 1? That is a question. So since I have still one prerequisite for course 3 from coming from course 2, I cannot take course 3 unless I finish course 2. So after node 1, I can take node 2, or after node 2, I can take node 1. And then after finishing these two, only I can take the node 3. So either the student can take course 0, 1, 2, 3, or course 0, 2, 1, 3. In this way, if I apply the similar concept on some graph, see how things are basically resolved. Let's take this as a graph where we have vertex A connected to vertex B and maybe C and maybe D, okay? And then we have some more connections from B to D and D to C and B to C and so on, okay? So how to actually find out the prerequisite idea? So we have four different courses A, B, C, D, and A has in degree of 0. So in this way, I can start taking course A first. Okay. So if I take course A, I will remove these edges from the graph. Okay. And once I remove these edges from the graph, then the in degree of vertex B will be 0. So after course A, I can take course B because this edge will be removed from the graph. So once I take course B, I can remove this particular edge. And this will allow me to take, similarly, I can also remove this particular edge, okay, because the vertex B will be removed from the graph. And after this, I will have a vertex D which has in degree equal to 0. And in this way, I can take the course D and I can remove this also, and then finally vertex C will have the in degree equal to 0. So if you look at this idea, logically this idea revolves around the releasing of a vertex and reduction of in degree. That is, you release the vertex from the Q, that is nothing but dq, okay, delete the vertex from the Q, and once you delete the vertex from the queue, you decrease the in degree of the vertex. And once the in degree of the vertex is decreased, if that in degree reaches to 0, that vertex needs to be selected. Look at this idea, what will happen here. Suppose I have same graph A, B, then D, then C, okay? And also this is connected here, and this is also connected here, okay? And this is the same graph, but what I'm doing here is I am adding one more edge in this graph from C to B. Okay, so now the problem comes after finding out a vertex with no vertex within degree equal to 0, that is A. I can release these edges, okay, but now I am not able to find out any vertex whose in degree equal to 0. And this gives me the idea that there is a cycle in the graph. So there are certain questions like this. How will you detect a cycle in the graph? So if you cannot proceed with breadth first search in the graph by releasing the vertex after decreasing the in degree, and if you cannot proceed, then that particular graph will have the cycle. So the concept which we have discussed is also called as topological sorting, in which we will first start with a vertex whose in degree is equal to 0, and we continue releasing the vertex uh, whose in degree is 0. So for example, if I have some edge like this here, then probably then I cannot find a correct prerequisite sequence because there is a cycle in this graph. So two concepts discussed. One is what is topological sorting, how breadth first search is applicable in topological sorting, and how breadth first search can be used to find out the cycle within the graph. Hope you understood. The idea cycle within the graph is very important to note here and the takeaway point of this video. Thank you.